From our bodies to our Earth's oceans and rocks, acids and bases play an important role in our lives and the environment around us. If you have tasted lemon juice or washed your hands with soap, you've experienced acids and bases. Scientists classify substances as acids, bases, also called alkali, or neutral, depending on characteristics such as taste and pH. Citrus fruits contain citric acid. Toothpaste is a weak base. Toothpaste neutralizes the acids in foods and protects tooth enamel. Acids taste sour. In fact, the German word for acid is sauer. Because acids can damage cells, our stomach needs a special lining to protect it from the hydrochloric acid used to digest our food. We are familiar with some acids. Citrus fruits, tomatoes, and vinegar are acidic. This pictogram signals that a substance is corrosive and can harm materials and/or skin if contact happens. Acids react with most metals including magnesium to create hydrogen gas and a salt. There are lots of different types of salts in chemistry. They also react with a group of substances called carbonates to produce carbon dioxide gas, salt, and water. Learn about the reactions of calcium carbonate, like limestone, in this article. Base is a corrosive substance is one that will damage or destroy other substances with which it comes into contact. By means of a chemical reaction, bases feel slippery to touch. This is because they can change the structure of proteins. A strong base can cause severe chemical burns because it starts to damage the proteins in your skin. Basic substances are used in many cleaning products. The simple chemistry in acid is a substance that produces hydrogen, H+, ions when it is added to water. A hydrogen ion is just the proton and no electron. If we look at the formulas of different acids, we can see that they all contain at least one H, hydrogen, for example, HCl, hydrochloric acid H2SO4, sulfuric acid HNO3, nitric acid. When we put a molecule of acid into water, it breaks apart. The science term for this is that it dissociates. For example, hydrochloric acid, HCl, dissociates into hydrogen ions, H+, and chloride anions, Cl. The chemical difference between acids and bases is that acids produce hydrogen ions and bases accept hydrogen ions. A base is a substance that neutralizes acids. When bases are added to water, they split to form hydroxide ions, written as OH-. We call a base that has been added to water an alkaline solution, but if we look at some formulas for bases, we can see that they all contain hydroxide, OH, ions, for example in OH, sodium hydroxide, caustic soda, NH4OH, solution of ammonia in water Ca, OH, 2, calcium hydroxide, builder's lime. If an acid and a base are added together, they react to form water, H2O, and a salt. An example you might be familiar with is brushing your teeth. The acid created from the bacteria on your teeth reacts with the base in your toothpaste. This reaction is called neutralization. A pH meter measures how acidic or basic a solution is. When we test a substance with a pH meter, we get a number from 0 to 14. This is a pH scale, and it can be used to compare substances. It is important to know that this scale is logarithmic. This means that a decrease in the pH scale of 1 can result in an increase of 10 times the concentration of hydrogen ions. Acids have a pH below 7. The more H+ ions, the more acidic it is, and the lower the pH will be. Bases have a pH above 7. pH 7 is said to be neutral. This means there is a balance of H+ and OH ions. Sometimes, the pH value can be less than 0 for very strong acids or greater than 14 for very strong bases. Knowing what students bring to the classroom can and should influence how we teach them. This study is a review of the literature associated with secondary and post-secondary students' ideas about acids and bases. It was found that there are 6 types of alternate ideas about acids and bases that students hold. These are macroscopic properties of acids and bases, microscopic properties of acids and bases, neutralization, acid strength, pH, and titration.